So in this video, I'm going to discuss sampling distribution, and this is the part 3 of our lesson in sampling distribution. And our objective, or the main topic for this video, is the mean and variance of the sampling distribution. And our objective is to find the mean and variance of the sampling distribution of the sample means. So we have here the mean of the sampling distribution, and according to this, the mean of the sampling distribution is equal to the mean of the population. So in the variance of the sampling distribution with replacement, if all possible random samples of size n are taken with replacement, the variance of the sampling distribution denoted by this symbol sigma squared, or sigma squared sub x bar, or the mean or the variance of the sampling distribution, is the quotient of the population variance and the sample size. In symbol, we have here the variance of the sampling distribution is equal to the variance of the population divided by the sample size. The standard deviation will be the standard deviation of the population divided by the square root of the sample size. In case that without replacement, if all possible random samples of size n are taken without replacement, the variance of the sampling distribution denoted by this symbol is the quotient of the population variance and the sample size multiplied by a correction factor, which is this: the population size minus the sample size, and the difference will be divided by the population size minus 1. Here we have the formula. As you can see, the only difference between with replacement and without replacement is this correction factor. And for the standard deviation, the correction factor is, we take the square root of the correction factor multiplied by the standard deviation. To give you an example, we have here, in the previous video, we have here the probability distribution 135, and we have the probability as 1/3 for all value of the random variable. So we have the mean here as 3. Computing the mean, we have 3. And the variance, if we're going to recall the formula in computing the variance, and that will be 1 minus the mean quantity squared multiplied by its corresponding probability. 3 minus the mean, which is 3, squared, this will be 0, and this will be 5 minus 3 squared, or 2 squared, 4 times 1/3. This is 4/3 plus 4/3, thus we have 8/3. So if we're going to compute for the mean of the sampling distribution, we have here the sampling distribution. And if we're going to compute for the mean, 1 times 1/9 plus 2 times 2/9, and so on, we can also obtain 3. So it goes to show that it is true that the mean of the population is equal to the mean of the sampling distribution. And for us to compute for the mean, or for the variance rather, of the sampling distribution, we have here the variance divided by the sample size. In this case, the variance of the population is 8/3 divided by 2, so we have here 4/3. So meaning the variance of the sampling distribution is 4/3. So for the second example, we have a school has 5,000 students with a mean weight of 80 pounds with a standard deviation of 20 pounds. If you draw a random sample 50 students, what is the mean, variance, and standard deviation of the sampling distribution? Since the sample is taken from a finite population, we can conclude that there is no replacement will be made. Hence, we must use the formula for without replacement. Since mean or the population mean is 80, hence the mean of the sampling distribution is also 80. Since the standard deviation is 20 and n is equal to 50, where the sample size is 50 and the population size is 5,000, we just plug it in our formula to obtain the standard error or the standard deviation of the sampling distribution. So we have here 20 divided by square root of 50, and then we have here 5,000 minus 50, 5,000 minus 1, and that is approximately equal to 2.815. And to obtain the variance, we have here uh, the square of the standard deviation. Squaring 2.815, it will give us 7.922. And that will be the mean. The mean is uh, 80. The standard deviation is 2.815 and the variance will be 7.922. And these will be left as your exercise together with this one. And that will be all for this video.